Hi, everybody, and welcome back to the Azure Database for MySQL monthly webinar. I'm Shreya R, Product Manager in the Azure Database for MySQL team. We are live today on YouTube, LinkedIn, and Twitch. For those of you who missed any of our previous episodes, you can check out the recordings on our YouTube channel. Our handle is at AzureDB MySQL. So here is the agenda for today's episode. We'll have two deep dive sessions, just like we did in the last month's webinar. First, Deepak Sengupta, a support engineer at Microsoft, will discuss load test emulation for Azure Database for MySQL Flexible Server using mysqlslap, which is a diagnostic program included within the MySQL Server binary. Second, Tameika Lawrence, program manager at Microsoft, will explain Microsoft Defender for Cloud support for Azure Database for MySQL Flexible Server, which basically enables effortless threat prevention, detection, and mitigation through very simple security management. And finally, as always, I'll share with you the latest feature releases and our upcoming roadmap. Folks, if you have any questions or feedback during the webinar, or if you just want to drop a hi and let us know what you'd like to hear from us in this session or in the upcoming session, please add a comment in the live chat window and we'll address them as we go through the session. And we also have our product expert, Sudish Narayan Swami, on the chat window to help answer any product questions that we are unable to address during the session. Now, let's get started with the very first section, load test emulation using mysqlslap. Load testing, as many of you are familiar with, is a crucial pillar of performance testing, especially for database workloads. MySQL is a diagnostic program which is included within MySQL Server binary that helps you simulate client load and measure performance as well as the overall reliability of your MySQL workload. I'd like to invite Deepak Sengupta to walk us through with demos how to use MySQL its benefits, as well as some do's and don'ts. Hi, Deepak. Welcome to the webinar and thank you for joining us today. Could you share a brief introduction about yourself before we jump into your presentation?
Thanks there. Hi everyone. My name is Deepak Sengupta. I work with Microsoft as a support engineer and I'm working with Azure Database for MySQL team. As part of this session, I'm going to discuss about MySQL Slap utility and its usage with Azure Database for MySQL Flexi instance. We can start off with the slides.
Thanks, Deepak.
Okay, so let's move forward. My SQL Slap is basically a benchmarking tool which is bundled with MySQL Server binaries. It's a powerful yet simple tool which helps us to perform stress test. Now it helps us to um, take informed decisions about the database server design in terms of SKU, in terms of your queries by looking into the queries which are taking high CPU or high resource consumption. So I'm going to show you a demo in my upcoming slide on how to use MySQL Slap with Azure Database for MySQL Flexi server. But first, let me explain you as to uh, how we can use this particular tool and how it basically works. So as I mentioned that MySQL Slap helps us with benchmarking by emulating client load. Based on the benchmarking result, it helps us to fine tune the database workload and the hardware resource that we have configured for our instance. Now, how exactly does it work in the backend? So basically, primarily, it's a command line utility which is basically has three stages in it. So we basically call or we execute this MySQL Slap utility using command line which runs in three different stages. So once we call the MySQL Slap utility, firstly, it creates a database, it creates a schema, it creates table, and it inserts data into it. Now, this particular process is completely dependent on the parameters that we are passing as part of the command, as part of the MySQL Slap command. Now, once the schema tables and the data is inserted, once it's created, it moves on to the second stage, which is basically it executes the query and the commands based on the supplied parameters, which helps us to emulate the client load. Now, uh, this is the actual stage wherein the MySQL slap utility, it executes the queries that we supplied and the parameters based on the parameters that we supplied, and it provides us with the actual result based on the test or the command that we are executing. Now, once the test is completed, the uh, processing moves to the third stage, it wherein the MySQL slap utility, it basically cleans out the data that it has created as part of the second stage. Now, during these three stages, stage one and stage three uses a single client connection. However, the stage 2, it basically uses multi-client connection, and this number of client connection that it uses is basically dependent on the parameters that we supply. So moving on to the next slide, we will look into how exactly we can install the MySQL slap utility. Okay, so MySQL slap utility, we can run it using the Azure Cloud Shell. We can run it on a Windows system, and we can run it on a Linux system as well. Okay. Now, for Cloud Shell, it is by default available with Cloud Shell. Now, in order to verify, I have provided I have provided a specific command which you can basically execute to check whether the MySQL slap utility is available on Cloud Shell or not. This is just for your good to have knowledge, this particular command which I have shared. Now, for Windows installation, you can browse the MySQL community downloader page to download the MSI installer, which is basically the MySQL Server installer. As I have mentioned that the MySQL slap utility, it is bundled with the MySQL Server package. Okay. The other option is you can basically download the zip file, which is which basically contains the exact set of binaries that we get after installing the MySQL server on a Windows system. Now for Linux, for Linux, we have a set of queries. We have a set of command, I would say. We have a set of command which basically installs the MySQL client package. Now, in Linux, the uh, MySQL slap utility, it is basically part of the MySQL client package as well. So, if we want to access MySQL slap utility on Linux systems, we have to install the MySQL client package. So, um, with this this is a very basic steps for installing the MySQL slap utility. With this, we'll move on to the next slide to understand how to use MySQL slap. Okay, so MySQL slap supports multiple options which we can specify using command line. As mentioned, um, as I've already mentioned multiple times, that it's a command line utility, and we can pass multiple parameters which can be used based on our requirement and based on what we would like to achieve out of our benchmarking test. So as part of this particular session, I'm going to discuss about few of the important parameters which are commonly used and which are very easy to use. So the first one being concurrency. So think of concurrency as number of users who are trying to execute a single SQL query. Okay. Now, with concurrency parameter, we specify the number of users that we want to stimulate for this particular for a particular benchmarking test. The second is iteration. It denotes how many number of times the specified set of users will repeat the same test. Okay. Third is basically hyphen hyphen create a schema. It defines that which is the user database. If we have a query, if we have a fixed query that we want to test for uh, as part of the benchmarking process, now for this particular user query we can run it against a specific database which holds its respective tables. So with hyphen hyphen create schema, we can specify the user database against which we would like to run the benchmarking test. The next is hyphen query, or you can say query as a parameter, which we will pass if we have a specific query. So as I mentioned, if we have a specific query in mind for which we want to perform a stress test or for which we want to perform a benchmarking test, we can use query parameter create um, along with create schema parameter. We can combine both to ensure that we are running the query against a specific database. Okay. The last one is auto generate SQL. Now let me tell you, this is a very useful parameter which makes our job pretty easy. Now with auto generate SQL parameter, how it helps us is it creates a database, it creates a table, it inserts the data in it, and it runs the query on our behalf. We need not specify any MySQL query as part of the stress test or as part of the benchmarking test. If we are using auto generated SQL as parameter, it automatically generates a SQL query and it automatically executes the query on our behalf and it gives us a detailed result. Okay. Now, um, let me quickly explain you a basic example of the command that you're seeing on your screen. So basically, what we are doing as part of this command that you are seeing, we are calling mysqlslap and we are specifying a server name, username, port number, and password. The server name, username, port number, and password is basically the um, is basically the server name of the MySQL Flexi instance for which we are trying to run the benchmarking test or the stress test. Okay. Now we are providing these parameters so that MySQL Slap can establish a connectivity with the MySQL Flexi instance. Now for concurrency, concurrency denotes 20 users who will be simulating this particular test, and iteration denotes each user will run this particular test 10 times. That's why I have mentioned iteration equals 10. I've specified a single query using the query parameter, and this particular query will be executed as part of the benchmarking test. Now, this particular query will be executed against load test database. That's why I have specified create schema as create schema equals load test database. So this is a existing database. Okay, with this, let's move on to the demo video wherein I'll explain you how things works. Okay, let's start by installing MySQL Slap on a Linux Ubuntu system and Windows. So first we'll check if the MySQL Slap or the MySQL client is available or not. So MySQL Slap hyphen version gives us the information whether the MySQL slab utility is available or not. Sudo apt update is basically used to update the app repository, and we are installing the MySQL client because MySQL slab is part of the MySQL client binary in Linux. So now that it's installed, we are checking and we verified that yes, MySQL slab is installed, and we are seeing the version of MySQL slab along with it. Okay. Now moving on to the ways of installation for Windows. So basically I browsed to the MySQL community downloader page, and from here, you can basically download the MySQL Server MSI installer, and you can install the MySQL Server setup to get the binaries, and from the binaries you will be able to get the MySQL slab. The other way is to download the zip file. So let me show you. This is the MSI installer, and this is the zip file. So I've already extracted it, and if you browse to the bin folder of the extracted zip file, you will be able to see the MySQL slab utility. There it is. Okay, now that we have an understanding how to install and how to use MySQL Slab, we'll look at the command line, how to basically use the MySQL Slab command. So I have already pre-created few of the commands for you. So I'll first copy it, and we will execute it, and I'll explain you what exactly this command does, what are the different parameters it has, and the results. Okay, so basically we are calling MySQL slap, and we are specifying host name. The host name is of the MySQL flexible server, which is running on 2 core, and general purpose. I'm specifying port number, username, and password. It's a SSL communication. Now the important part is the parameters, which is concurrency. So the concurrency parameter is basically of 300 value, which means that 300 users will be part of this particular test. The iteration value, is basically 30, which means 300 users will be executing the queries 30 times. The number of queries that I have mentioned is 3000, and I am also using a auto generated SQL parameter. And this auto generated SQL parameter, as I have mentioned, it will automatically generate the queries. And hyphen hyphen verbose is basically it will give us a verbose output of the benchmarking test that I am going to execute. Okay. So basically, to sum it up, 300 users will be executing 3000 queries, which will be auto generated. And this number of times the 300 users will be executing 3000 queries is 30 times. Okay. So now that we have an understanding of this particular command, we will hit enter, and it will ask for a password so that it gets a connectivity to the MySQL Flexi server, and it uh, initiates the test. So we'll enter the password and hit enter. Okay, so now that the test has begun, you see there's a MySQL slab database that got auto created as part of the test. Now this also has a table T1, which we'll get to know. See, now when we are running show process list, we do see that MySQL slab database is inserting data into it so that it can use this particular database and the table T1 for it to it will use the data from this particular table T1, which is part of the MySQL database as part of the stress test. So the queries that will be generated will be auto generated queries, and the data that the query will fetch will be from the uh, T1 table, which is part of MySQL slab. Okay, it's still getting executed. We'll just wait. Okay, now we can see the execution is complete, and we can see the database is also gone. So it as part of the stage 3, it has performed a cleanup process. Okay, so let's look at the benchmarking results. So the average number of seconds it took to run all the queries is basically 2.816 seconds. So basically it gives us a average execution time, it gives us a minimum execution time, it gives us a maximum execution time, and also it gives us the output that how many clients executed the query. So here you can see 300 clients executed this query as part of the concurrency parameter, and average number of queries per client is 10, because for each of the iteration each client executed 10 queries. So 300 clients executing 10 queries per iteration is 3000. Okay, let's move on to the next command that we have. So this command is slightly different from the first one. So let me call out the differences. The concurrency is basically 200. Iteration is 10, which means 200 users executing this particular command or the SQL script 10 times. Number of queries is 4000. Okay, this is the highlighted one, is the parameter which is a new parameter that I have added. Number in it calls equals 10. Number in it number char calls equals 20, which means 10 columns will be added into the T1 table, which has a data type of integer. Number char calls equals 20 means 20 columns will be added into the uh, table T1, which will have data type of varchar. So these are the two new parameters that I have added. Now the auto-generated SQL will be used to generate SQL scripts automatically. So let's execute this particular query and we'll see what difference it makes in the backend. Okay, now it has initiated the command. So we'll do a refresh. We can see the MySQL slap database got created. We'll see the content of table T1. Now, as you can see, it has 10 columns with data type as integer, and it has 20 columns with data type as varchar. Sorry. So basically what I'm trying to explain you is, based on our requirement, based on our infrastructure, based on our application, if we know that okay, this particular table will have so many columns with respect to data type, we can invoke, we can simulate that kind of test using MySQL slap utility. Now this particular test that is running, the command that I have supplied is against a larger database, so it will take comparatively more time than the first command that we executed. So we'll just check if it's completed or not. Okay, so it is still running. So what we can do is we can probably take a quick look at the resource utilization also in the meantime while this particular query is in execution phase. So let's refresh. Okay. So you see in the very first graph, the CPU spike, we see a CPU spike, which is approximately at 43%. This spike is because of the first command that we executed. Okay, we can see there is another spike in the CPU utilization. Now this spike is because of the current command that we are executing against a larger database. Now, since the database, or I can say against a larger table. Okay. Now, since the table content is more, the number of columns is more, the number of queries to execute is more. That's why the resource utilization will go up. The amount of time to execute the query will also go up. So this helps us with an understanding of a real world scenario. Okay, so here we can see the output. We do see a spike in the execution time. So what I was saying is it does gives us a feel of the real world scenario, wherein uh, we might have similar scenarios wherein the data load will be higher at times in a specific scenario. And for those scenarios, we can basically look into the resource utilization, and we can basically understand what is the resource utilization or the SKU. Okay, we'll quickly move on to the next command that I have pasted over here. So it is using query parameter, and this is the query that it is using. So it's a select statement. It's a complex select statement that I have specified. Now for this particular command, what I am doing is I'm calling MySQL slap, and I'm running it against a specific database using create schema, which is the database specified is test load, and I'm using hyphen query, and the number of users that I am running this test for is 50 users with 5 iteration, which means 50 users will execute the same query 5 times each. Okay, so I've already entered the password. I'm waiting for this particular test to complete. Now let me tell you, this particular query that I have executed, it's a complex query, and the database or the table against which this particular query is executing has approximately 5 million records. So we'll just wait for the output to load. Okay, we'll also look at the resource utilization. We don't see any dip in the resource utilization as of now, and we do see a count of 5 million records in this particular table, and we don't see any reduction in the CPU utilization. Now, since I know that this particular query that I am running is a time taking query, now just part of this demo session, I'll kill it, because I know myself that the CPU will spike up to 100% and it will not give us a result. So all that I'm trying to explain is, if we have a query, we know that this particular query will be executed by n number of users. We can simulate a test case scenario to understand if the current load or the current resource of this particular server is enough or not. So I've killed this particular command using Control C, and we move on to the last query that will be running, the last command which we will be using. So this particular command, I have used a insert statement against a specific table. So I am running it against employee table, which has 1,000 records as of now. And as part of the mysql/slap command, what I'm doing is I'm trying to insert data into this particular table. So concurrency is 10, which means 10 users will be inserting data, and each user will be inserting data 100 times. Okay, okay, so it was pretty quick. I can see the result, I can see the output. Number of client is 10, average number of queries per client is 1. So now if we look at the table content, it is 2000. So because of the insert operation, the table content has increased. Now for this, these were few of the scenarios, few of the parameters that I explained. Now I would request you to explore more on the mysql/slap utility, and you will be you get yourself familiarized more on the mysql/slap utility and how to use it on your environment or on your test case scenario. Okay, moving on to the next slide, um, which is basically do's and don'ts of MySQL/slap utility. So as part of the do's and don'ts of MySQL/slap utility, I would like to highlight a very important point, which is the first one. Leverage empty or default MySQL/slap database for testing. Now, When you're using MySQL Slap utility, and if you're using the parameter, which is basically auto generate SQL, what it does is it basically creates a database, it creates a table, and it inserts the data in it. And after the run, it cleans out the information, it deletes the database. Now, if you're running auto generate SQL against an existing database as part of the cleanup process, it might delete or it might clean up the database that you have. So, uh, keep in mind, if you're using MySlap with auto-generated SQL parameter, ensure that you're using it only against a empty database or against the default MySQL Slap database. Next, thoroughly test MySQL Slap in your lower environment before moving on to the production. Now, you don't want to perform anything or you don't want to change anything in your production which can impact you. Now, just to avoid this particular scenario, I would highly recommend that you perform this test in your lower environment thoroughly. You get an understanding of what you are doing. You get yourself familiarized with the utility, and then you can move on to the production. Use realistic data sets and queries. Yes, it is very important because if you want to perform a benchmarking of your application, you have to ensure that you're using the, if not the actual set, but a similar set of data. It can be a table with a similar set of columns, similar set of data type, a similar size of table. So this is something you have to keep in mind. Adjust benchmarking parameters accordingly. So this point is kind of similar to the previous point. So with respect to parameters, like if you know that yes, this particular table will be accessed by 1,000 users, so in that case, if you want to perform a benchmarking test, ensure that the concurrency parameter is set to 1,000, and similarly for the other parameters as well. Monitor system resource during the test. Yes, this is very important to get an understanding if the SKU that you're using is kind of sufficient for your application or for the database from which your application is going to pull out data or it's going to insert data into it. And the last one is just to ensure consistency with respect to the benchmarking result. Please ensure that you running this particular test multiple times before getting into the conclusion. With this, I will probably end my MySQL Slap session, and I will um, move on to the next topics. Thank you.
Thank you for the explanation, Deepak. This was super helpful. Love the demo, and I love how simple it is to use the tool, as well as the amazing range of benefits that the tool provides. So, folks, be sure to check out the blog post that Deepak has put up for a detailed write up of performing the load test emulation for flexible server using MySQL Slab. But thank you again, Deepak,
Thank you.
and thanks for joining us so late in the evening.
No problem.
Perfect. So, moving on to the second topic of the day. Last week, we announced a major security milestone, the general availability of Microsoft Defender for Cloud support for Azure Database for MySQL Flexible Server. Microsoft Defender for Cloud is an application protection platform that provides unified security management and advanced threat protection across hybrid cloud workloads. Inviting Tameika Lawrence, program manager, to show us how to make use of this new integration of Defender and MySQL Flexible Server. Welcome, Tameika. Thank you for joining us today. Tell us a little bit about yourself before we get started.
Thank you, Shreya.
Uh, can you give us a little bit of an introduction before we get started?
Yes. Hi, everyone. So my name is Tameika Lawrence, and I am a security product manager for the Azure Database for MySQL team.
Perfect. Over to you for the deep dive and the demos.
Okay, so to get started, today introducing the Microsoft Defender for Cloud for Azure Database for MySQL Flexible Server support that is currently in general availability. I'm going to start by giving you a brief overview of the feature. So to start, Microsoft Defender for Cloud is an application protection platform that simplifies security management for users. And it does this by securing services against cyber threats and vulnerabilities. And so essentially, the average user doesn't need to be a security expert in order to safeguard their environment and ensure the health of their security posture for their flexible server. So specifically with the advanced threat protection feature, it does this by using integrated security monitoring to detect anomalous database access and query patterns, as well as suspicious database activities to provide security recommendations and alerts. So when it comes to those security recommendations and alerts, they're essentially categorized and assigned by severity levels that will indicate what triggered them. It will indicate the associated MITRE attack technique and the seriousness of the threat, as well as identifying the steps that you can take to remediate the threat. And so it takes a lot of the guesswork and the effort out of coming up with a mitigation plan and providing that strategy for you. So moving on to the next slide. I want to call out some of the limitations that are currently present when it comes to using Defender for MySQL Flexible Server. So specifically in migration scenarios, when a user is migrating from an Azure database from MySQL single server to flexible server that has Defender enabled, the enablement state is migrated. So meaning it'll know if Defender is enabled or disabled on the single server and migrate that state to the flexible server. When it comes to the additional settings that are applied at the resource level in single server, there are some that are going to be automatically configured, like under the hood, while there are others that you'll need to manually configure in order to achieve that parity on the new flexible server when setting up the security alerts. So now I'm going to go into a quick demo for Defender for MySQL Flexible Server support. So in this quick demo, I'm going to go over enabling Microsoft Defender for Cloud for an Azure database for MySQL Flexible Server, disabling Defender for that flexible server, as well as reviewing some of the security recommendations and setting up an email alert. So to start, I've already navigated to a flexible server in my Azure portal. And if I go down to the security options, I'll see that Microsoft Defender for Cloud is listed. Selecting it, it's going to open up to this main page where I can see that the enablement status is currently set as disabled. If I wanted to enable Defender for Cloud on this flexible server, I would just need to click the enablement button and kick off the process of enabling Defender. So this takes about 1 minute or so, but it's pretty quick. So now that the operation has completed successfully, I can see that in the center pane, the enablement status has been updated from disabled to enabled at the subscription level. If I wanted to disable Defender for Cloud, I would just need to hit that configure option. It's going to open the server settings for Defender where I'll see that there's an on and off option. I can hit the off option, hit save, and then it's going to disable Defender on my flexible server. And so we have the disablement operation completed successfully. And if I navigate back to that main view for Defender on this server, I'll see that the enablement state has been updated once again, this time back to disabled. So now I'm going to navigate to another server in my subscription that already has Defender for Cloud enabled on it. And so it's had some time to monitor and scan the database and provide a security recommendation. So navigating to Defender on this flexible server, I can see that there's already one security recommendation that's been provided. If I go down to that center pane, I see that it says MySQL flexible server should have Azure Active Directory only authentication enabled. And I can select this. It's going to open a more detailed view about this security vulnerability that shows that the severity is listed as a medium. The freshness interval is on 30 minutes. And so the feature is scanning my database every 30 minutes to see what the status of this vulnerability is. And then the associated MITRE attack technique is listed as initial access because the vulnerability has to do with authentication. So the description is going to give me a little bit more detail that essentially disabling local authentication and allowing Azure Active Directory only would improve my security by ensuring that my flexible server can only be accessed by Azure Active Directory or Microsoft Entra now identities. Taking a look at the remediation steps that are provided underneath the description, I can see that it provides me a detailed outline of the instructions that I would need to remediate this threat. And so that's going to be navigating to the authentication setting, changing the method to Azure Active Directory only, setting an identity on it, and then assigning an Azure AD admin. If I take a look down at the bottom of this page, I can see that there are a couple buttons for me to take action or assign an owner. So essentially, I'm going to hit assign an owner. And what this is going to do is that I'll be able to set an assignment for this particular remediation task to someone. So entering an email address, I'm going to assign it. I'm going to enter my email address and just assign this task to myself. I also have the option to set a remediation timeframe or a due date. So I'm going to change the due date to a week later for the 15th. And then select to notify the owner weekly so that I'll get a weekly email alert that this remediation needs action and needs attention for me to complete. And then I'm just going to hit save and create, and the assignment has been created. Now, optionally, as we see that there's also a take action button if I wanted to remediate this potential vulnerability right now. So hitting that take action option, it's going to take me back to the main view where I can navigate into the security settings and select authentication. So here I see that MySQL authentication only or local authentication is currently selected. I can update this access method to select Microsoft Entra authentication only. I see that I already have an identity that's selected for me, that's filled in, that's my identity, so I'll use that. And then I'll just need to select a Microsoft Entra admin. Microsoft Entra admin, I'm just going to set the admin to myself. So when the pane opens, I'm going to search for me as the admin, select and hit save. So now I'm just going to update all of the settings that I've now applied, which is changing the access method to MS Entra auth only, filling in a user managed identity, which is my identity, and then selecting myself as the Microsoft Entra admin, and then hitting save to update these settings. So now I've called out for initial access. And if I go back to this page, I'll see that the recommendation is still listed because as we reviewed before, it's on a refreshness interval of 30 minutes. And so within the next 30 minutes, when the Azure threat protect the advanced threat protection feature were to scan and would see that I've updated my authentication method to Azure Active Directory or Microsoft Entra only authentication. And essentially, this recommendation would no longer be there. And so this concludes our demo for today for Microsoft Defender for Cloud for an Azure database for MySQL Flexible Server.
Thank you so much,
Thank you
Tameika,
so
for
much.
the insightful demo. Yeah. Looks like we can do a lot with this new integration to improve the MySQL workload security posture. So thanks for sharing this with us. Folks, do check out Tameika's blog post for a detailed write-up. And here's the link to the blog post, which also has links to the tutorial that you may want to check out. Thank you again, Tameika, for your time with us today and for joining us despite it being so early in the day for you. Perfect. Let's move on to the final topic of the day, which is the latest feature releases and roadmap. In the past month, there were two major feature releases. First, as Tameika announced earlier today, the support for Azure Database for MySQL in Microsoft Defender for Cloud, which is now in general availability. You can now easily detect anomalous activities indicating unusual or potentially harmful attempts to access or exploit databases without the need for advanced security monitoring systems or security experts for that matter. Second, long-term retention of backups is now in public preview. Previously, Azure Database for MySQL allowed for automated backups as well as on-demand backups to be retained up to 35 days, but with long-term retention or LTR, you can now retain the backups up to 10 years, further aiding your audit and compliance needs. This feature will be GA'd by the end of this quarter, and for more details, you can check out aka.ms MySQL Backup LTR. Finally, leaving you with the upcoming roadmap. On-demand backup and export in private preview. This provides an ability to export at moment physical backup of the server to Azure storage account or Azure Blob storage using Azure CLI. And once exported, these backups can be used for data recovery, for migration, for data redundancy and availability, or even auditing and other purposes. We plan to release it in public preview this quarter. Support for 32 TB storage currently in private preview. You can actually expand your storage for business critical SKU up to 32 TB. It will go GA in this quarter as well. Next one, MySQL CLI for external migrations. Import CLI for external migrations is currently in public preview. This tooling is a single CLI command which will allow you to achieve simple and fast migrations of your heavy workloads, greater than 1 TB from external sources to Azure Database for MySQL Flexible Server. It's so fast that you can actually migrate around 1 terabyte of data in just around 23 minutes. Azure MySQL import actually underneath the covers uses physical backup copy obtained through a Quaterna Extra backup stored in Azure Blob storage to provision and restore to MySQL Flexible Server. This feature will be GA'd within the next couple of months. Flexible maintenance options, which allows you to reschedule maintenance windows and even instantly initiate maintenance with the reschedule now option, will be in GA this quarter. Near zero downtime maintenance for HA enabled servers, which is a feature designed to reduce the maintenance downtime for HA enabled servers, ensuring that in most cases, the downtime is around 40 to 60 seconds, which is especially critical for businesses that can't compromise on HA and require a minimum interruption in their database operations. This will be GA in this quarter as well. Accelerated logs feature for business critical SKU, with which you can actually see up to 2x performance enhancements at no additional cost. With this feature, we also see a significant performance and price performance enhancement over AWS RDS, Aurora, and Google Cloud SQL for MySQL as well. This feature will be GA in early Q3 of CY24. The last two, error logs and server logs, which is a feature that allows you the option to view, download error logs under the server logs option for up to 7 days to analyze and troubleshoot issues. It's currently in public preview and will be GA'd early next quarter as well. And finally, MySQL discovery and assessment in Azure Migrate, about which we talked in the previous webinar. You can use Azure Migrate service to discover MySQL servers in your environment, assess them by identifying their compatibility to move to Azure Database for MySQL, and also receive compute and storage queue recommendations along with their costs. This is currently in private preview. So if you wish to try it out, do write to us. We're targeting late Q2, early Q3 to go to public preview and would love your feedback in the meantime. So if you want to try out any of these features which are in private preview, do write to us at Ask Azure DB for MySQL at service.microsoft.com. Before we close out, I want to leave you with a reminder. Single server will be retiring on September 16th this year. So if you haven't already migrated, please upgrade to flexible server right away. Compared to single server, flexible server actually provides you 266% better performance per dollar, 117% better performance, and 54% lower latency. So all the more reason for you to move to flexible server right away. To upgrade, we have multiple options as well. The recommended one is the Azure MySQL import CLI command that can easily migrate large workloads in minutes. We also provide in-place auto migration, and you can also use Azure Data Migration Service or Azure DMS for the migrations. We'll make sure to put the links to the forms for Azure for in-place auto migration as well in the description when we are done with the session. Folks, that's all for today. As we close out, as always, I'll leave you with four things. First, check out our contributor initiative. Start contributing today and get recognized with badges, with official recognition, and more. The badges are really cool, folks, so please do try it out. The second one that I want to leave you with is to learn more about our service. You can use these resources or feel free to reach out to us on our email ID. Third, stay tuned for more updates and announcements by following us on social media and subscribing to our YouTube channel. Our handle on YouTube as well as Twitter is at Azure DB MySQL. And finally, if you want to feature in our upcoming webinars or collaborate with us on any collateral, fill out this form and let us know. Also, you can use the same form for any feedback for the session or if you have any requests or suggestions for the topics we should be covering in the upcoming sessions. Thank you all for tuning in. We I hope you enjoyed the episode. We'll see you all in our next session next month. That will be on the that should be on the 8th of May, 7:30 a.m. Pacific time. Thank you.